Now, before I continue, let me just remind everyone that there will be time for questions at the very end. If you have a question, just click on raise hand, write down your question in the appropriate area, and when you finish writing the question, just click on send at the very bottom of that window, and I'll answer them to the best of my ability. Again, all you have to do is click on raise hand. In the question area, write the question that you have. And when you finish writing the question, just click on send. And again, I will try to answer them at the end of the session to the best of my ability. Okay. Now, the subject, as I said, is that we're going to be talking about is ToolBox cycles. Now, what exactly is ToolBox cycles? Well, ToolBox cycles is what we call a canned, closed procedure that we've created inside SolidCAM to do many different types of operations. For example, creating a closed slot as shown over here, O-ring operations, special operations specifically made to do those operations. Even though I could do these in a profile, but in profile then I have to give all the different parameters that I need to do if I want to go down in the middle, for example, and then go off to the side. All this is done automatically inside our ToolBox operations. Everything is a closed closed cycle inside the operation itself. The idea behind this is to make programming time a lot shorter for these typical types of shapes that we may have. Okay? Again, this does not mean that I can't go ahead and do the operations in other options such as profile or pocket or whatever, but the idea is that this is made a lot quicker and a lot shorter programming time as far as the way we do this now. Okay, first of all, where is the toolbox located? If I go to my toolbox, to my ribbon on top, my SolidCAM operations ribbon on top, if I open up, if I click on 2.5D, at the very bottom we have toolbox cycle. We also have it inside our operations by right-clicking on operations and adding a milling operation, going to toolbox cycles over here. So we have it located in two places. Now, let's just take a quick look before I exactly show you each one of these, or most of them at least. Let me just go inside the window, the actual operation itself, and let's take a look exactly how it's actually built, what we're actually looking at. When you open up the toolbox cycle operations, you'll get the window as you see it over here. Now, this looks like your typical SolidCAM windows where you have first your geometry, your tools, levels, technology, and so on and so forth. But over here we have what we call technology. And in this area, by clicking over here on that button, we have the list of all the different types of cycles that we have inside the toolbox cycles, whether it be a spiral open slot, whether it be a spiral open slot that's wide and then you want to finish off the edges, closed spine slot, you want to do the spiral location, a regular slot where you want to also open it up on the sides, nub cycles, which I'll actually show you later on as we go through the cycles itself, a regular closed spine, a regular slot shown over here, a simple open slot on both ends going back and forth, corners, O-rings, a regular circle doing it in a spiral way. All these operations are located within the technology field of spiral open slots. Now, let me just close this operation now. And I'll actually start by going into the operations that I've already created, and I'll explain to them one at a time to show you exactly what we have over here. Okay, in our first part of the first area on this part itself. By the way, this part itself is just a part that we built to help demonstrate, to show the different options that we have inside the toolbox cycles. Now, let's first take a look at this area over here. This is a slot. It's not too wide, but the slot that the way I'd like to open it is actually go through the slot in a spiral cut on this surface itself. If I were to open up the operation itself, you can see that from my list of different excuse me, for the different cycles, I chose the spiral open slot, the very first one. And of course, we have our geometry area as shown over here. Now, whenever you pick any one of these options, you will always have a picture over here showing you exactly what the tool path is going to do, what kind of tool path you're going to get. And it'll also show you what you actually have to pick as your geometry. For example, over here it shows this line and this line as the lines that had to be picked for your geometry. If I were to click on show over here, because I already did create this, you'll note that I already chose these two lines as my geometry, and it does not make a difference as to which directions the geometries actually, the chains themselves are going. It's just important that you actually pick them, but it does make a difference what directions they're in. Now, as we go further down, of course, we have our tools. In this particular case, I have a 10mm end mill. We have our levels, as usual, and then we have our technology. Now, let's take a look what we have actually inside our technology. In our technology, this is actually controls exactly what we're doing. And the idea is that you don't really have, you just tell it a few parameters and it'll work everything out for you. Now, as far as roughing goes, we can tell to go down every 10mm. In this particular case, that's the entire step. And we can control the cutting angle with a minimum or maximum angle, just like we have in iMachining. Although do not confuse this with iMachining. The feeds and spin rate is put in by the user himself inside the tool area. Okay? But let's go back into technology. We have the minimum cutting angle and the maximum cutting angle, which you yourself decide. And you could also, instead of doing that, you can use step over, where you tell it what's your minimum and what's your maximum step over that you want. Okay. We also have retract height, because what actually happens over here is that it repositions itself every single time it goes back and forth. So for the repositioning, we're going to tell it how much we want our retract height to be. We can work with an offset on the wall and on the floor, and we can also do, if we want, a finish cut, where at the end we'll also do a finish cut on the wall itself. Let's just take a look at the actual, and by the way, that's all you have to put in. Let's just take a quick look at the simulation itself. And we'll do this using the top view. Now zoom in. What you'll see is as follows. You'll see that it actually does that spiral cut along inside that slot itself. And that's how it's opened up. Let's just do it a little differently using the Solid Verify. As you see, it's just going across, working in that slide using that spiral type of a tool path to work that out. Okay, so let's now go to our next operation. And this time, we're going to do the exact same thing, but this time the slot is a wider slot. So in this particular case, I want to have my spiral cut in the middle, but the ends, I want to go back and forth on this wall itself in regular straight slots. If I were to open up that particular operation, you'll note I picked from my list spiral open slot wide, where we'll have the slot going down the middle, the spiral slot opening up the part down the middle, and then we'll have straight cuts on the wall itself towards the edge. Again, my geometry is picked the exact same way as in the previous operation. And again, the direction does not make a difference. I'll use the exact same tool, my levels. Now, in my technology, we have the exact same options, but with a little few extras. For example, our moat width. What's the width that we want our moat to be? In other words, the slot, the spiral slot that actually is created in the middle, what's the width that we want to have it? Now, of course, we still have our retract height as it repositions itself. Now, since I said at the very end, we have step overs, how much towards the wall itself, we have control of what the parallel cuts will be, the distance between one to the next cut. Of course, we can tell it also to go one way or zigzag back and forth. And here, just as before, we have our wall offset, floor offset. Something else I did not mention in the previous operation, we have that there as well, is the extension. How much do I want the tool to go actually past that line itself, the edge itself? And here as well, we have a wall. We can do a wall finish. We can work as a floor finish and a wall finish as well. Let's take a look at the simulation in this part itself, in this particular operation. And I'll zoom into that area. You'll note again, it's going across. Let me just get rid of the tool. Opening up the slot as shown over here, and then finishing off the edges as shown over here. Finishing off the wall, stepping over every millimeter. First opening up in the middle, and then working its way towards the side. Now, these are canned cycles which are automatically created. All you had to do was just choose the first chain and the second chain. You didn't have to connect anything at the end over there to make any kind of a sketch, and you're just told to go past the edges by the amount of 10%. So let's now go to the next operation. The next operation is also a wide side, however, it's closed at the end. So if I have to go into the next operation, you'll see again we'll be creating that moat in the middle, but then we'll be clearing off on the sides as shown in this picture over here. In this particular case, the geometry as shown over here, and since we do see arrows over here, so the direction is important. But all you have to do, however, just pick this area over here. You do not have to close it. If I were to show you the geometry itself, you'll see that all we have here is this area picked up until there. You do not have to close this at all. Again, we have our tool, we have our levels, and if we're going to our technology, it's the exact same thing we had in our previous operation. The minimum maximum cutting angle, moat width, retract height, and step over, as well as the finishes and the extension at the edge over there. Taking a look at the simulation of the toolpath itself. Let me just zoom into this area over here. And as you can see, it causes that moat in the beginning and then clears off the sides. In this particular case, it's doing zigzag on the part itself. You can see that by going by these lines over here as it goes zigzag, and we just run the simulation one more time showing the tool. You can see it going across. Ooh, I went pretty quickly. Let me slow it down. You can see the toolpath that's going over there, and now, well, as you can see, it went up and it just went one entrance over there and then cleared off going zigzag on the part itself. Okay, so let's now go to the next operation. Now, in the next operation, we have a slot that we want to do over here, this regular closed slot. And this is a very typical situation where I want to first go down into the slot, down the middle, and then work off closer to the sides. In this particular case, Let me just open up the operation itself. As you can see, it's called additional zigzag slot, where it first goes down in one area, down the middle, and then it clears off once it gets to the bottom at the edges. Again, I'm using the exact same tool. I have my level of 10 millimeters in depth. And in my technology, I want to step down every 5 millimeters. And then we have our ramping width. You note it goes down in a zigzag fashion to its depth. Now, the width of that zigzag is controlled over here, and the angle of that zigzag is controlled over there. We have our parallel cuts as far as how wide we want our parallel cuts to be, and over here as well we also have wall and floor offsets. If I were to show you the simulation of the part, and I'll do this one step at a time so you can see this a lot clearer. We have our tool going down, zigzagging back and forth until it gets down to 5 millimeters as shown over here. Once it gets down to 5 millimeters, it goes across, cleaning it up, and then it'll go down to its next level. Again, towards 10 millimeters, clearing off the bottom, and now it'll start working on the sides itself, clearing off the sides as shown over here. If I were to look at it in the top view, move this off to the side, you can see they have our middle line over here, and then it moves off to the side itself. Okay, so let me go now to my next operation that we hear. The whole idea behind this, by the way, again, just to remind you, is that we already have closed cycled moves that are automatically controlled by the program itself. Okay, let's go to my next operation. And my next operation is for this slot over here. And we're going to call this simple slot. Now, what actually happens here? Many times, and we've seen this in the past, what you want is you want to have the tool working on the simple slot over here, but when it gets, we have our geometries that we pick this edge and then this edge, but what would normally happen in your regular profile operation is that when it gets to the edge over there, it'll go up, go across, and then it'll go back down and then cross. And what you'd like to do sometimes is that instead of going up, which is a waste of time going up to your clearance level, you'd like to just keep the tool all the way down, just go directly across. Now, what people have done also in the past is they've created sketches where what they do in the sketch itself, they have a sketch that goes from here and then it'll past here so that the tool will go past here, and they create one sketch that'll actually do the motion that they want. So instead of creating a sketch, what we've done is we've created a CAN cycle called simple slot as shown over here. You can see the tool path is going to be exactly as shown over here, whereas the geometry, it's just these two lines. Again, we have our tool level, we have our technology. Now in our technology, all we have to do is tell it how much we want to step down each time, and if we want to do offset and finish. Let's just show a simulation. We have our tool going down, going across, and then going back out. And that's it. Very simple. Now let's go back. Now let's go to this next slot over here. Now this is a typical case where you'll have a slot, and many times all someone wants to do is just take a tool that's the exact width of this slot over here and go down the middle of that slot. Excuse me. Just a moment. Okay, so what people used to do is they used to create a sketch with a line going down the middle and then trying to work it out that way. What we did was make a very simple operation called simple slot, where all you have to do, if I were to open up the operation itself, sorry, wrong one. The closed slot just goes down the middle, as shown over here. The actual geometry is just the outside edge. You don't have to make any kind of sketch in the middle. Of course, the tool in this particular case, I used a 10mm end mill, which is the width of the slot itself, and we have our depth. Now, in our technology, we have step down. What does the step down actually do? What kind of step down are we having? Or how will it work as it goes down? What we actually wanted to do is to have it go in, but as it goes across on the center, it'll also go down at the same time. So it'll actually zigzag its way into up until the very, very bottom. And the amount that will go down each time is 2mm. If I were to just show you a quick simulation of what actually happens over here, you'll see that the tool goes down in a zigzag fashion. You know, as it comes here, it actually goes across and goes down at the very same time. So we have a crisscross. Once it gets to the bottom at minus 10mm, then it does one pass across the bottom and then picks itself up. And that's all it does. So if you need an operation like this, which I've seen, by the way, there was a customer of ours, which I've seen in the United States that we had once, that had a part where the entire part was full of these type of slots, where they were about 3mm in width, and he had about 300 or 400 of these slots. I couldn't even count them. So he just originally, with the way he used to do his created line in the middle, very tiresome operation, but all he had to do now is just create the geometry just by clicking on the face by multi-chains. And he had this use the actual geometry that was on the part itself without creating any lines in the middle. Made life a lot easier for that person. Okay, now the next I'd like to show you is also a type of a slot, but this time it's closed at the end. If I were to open up the operation itself, this is actually called a spine slot. Even though in this particular case, it's not actually straight, it's not straight as shown in this picture, but it can be used in this case as well. And it actually has a specific way it acts when it goes around the corners. Choosing it from here would be, as I said, the spine slot. And my geometry is the edge over here. No need to close it at the end. Again, we have our tool, we have our levels, and we have our technology. In our technology, we have our step down. We have something called tolerance, which controls as it goes around the edge, how close do I want those points as we go around the corners itself. And I'll show that to you as we show the simulation. And we have, of course, wall and floor offset if needed. Let's take a look at the simulation itself. I'll show this from the top view. From this point over here, and I'll do this one step at a time. Note the tool goes down, goes across. Now, note as it turns the corner, it doesn't do it as one swift arc movement. It actually has to have the tolerance. This is where it uses the tolerance of 1mm between each turn point over there. As it goes down the middle, it gets to the end. Now, note what happens now. It'll go off to the side and already clear off the side over here. No, it doesn't go to the beginning, but it actually starts from here, clearing off the side itself, then going across the other side, and then finishing off the part as shown over here. Now, the next operation I'd like to show you is actually something that has been requested from us for a while, and that we actually now put it in. Now, what I'd like to do actually is machine over here, but I do not want this floor actually to break off from the part itself. So what you used to have to do is you used to have to build bridges. You used to have to create a geometry that would go from here to here, then another one that would go from here. No, you have to create geometries in order to do exactly what's shown over here, so that it doesn't mill out this area over here. Today, we've actually created a new operation for that, where it's called 4 nub cycles. In other words, will create those actual nubs automatically. My geometry in this particular case is my entire pocket as shown over there. My tool, my 10 millimeter end mill, my entire depth up until this floor over here is 10 millimeters. Now let's go into my technology. If we go into the technology field, we have our step down. In this particular case, I'll do it one shot. And over here we have our bridges that we want to create. Our bridges are shown over here. We have the amount of bridges we want. In this particular case, I want to have 4 bridges, and it's going to be done automatically. By meaning automatically, it's going to be placed here exactly automatically according to the mathematics of the part, exactly where it's going to be placed on each one of these part on these edges itself. We have here the bridge width, the actual width of the bridge over here, and the thickness. How thick do I want the floor itself to be over here, between the surface and this floor, of a 0.5 millimeter in this particular case. And of course, we have a wall offset and a floor and we have a wall offset as shown over here. Now, let's take a look exactly how this works. Oh, before I continue, we have the bridges what we call automatic, but we also have a different option called manual, where I can actually create and tell it at what point I wanted to create a bridge. So if I were to go into manual and do bridge positioning, you'll note that there's nothing here. However, if I were to click, I want to have a bridge over here. Note it adds itself to this window over here. I want to have another one over here and another one over here. It'll create the point where I have it. I can have it at 3 points. I can add as many as I want. I can add another one over there. I can add another one over there. In other words, I have complete control manually of where I want those bridges to be. Okay, I'm going to run the simulation. Let me go back over here. I want to have this first automatic. Run my simulation. And note it'll go down. And note it went down 9.5 millimeters. First, it clears up everything up until that floor. And then as it continues now, it'll go in that area, the next area, jump up, allowing room, creating actually those bridges as shown over here on the part. Let's do this one more time using the solid verification. We have the tool going down, and then on each wall itself, automatically creating those bridges over here. This is helpful, especially when you're holding the part very close to the floor and you don't want to break off the very bottom part, the very part of the floor itself. You may want to do this a little later on by hand or by whatever means you want to do it. Okay, I'm going to jump now towards some other operations that we have here. Another one we have here that's very useful is actual cornering, where I have a corner that I want to use, used to use a profile operation, And what happened in the profile operation, in order to do this edge, I would actually create just that one geometry. And if I do a clear offset, it'll actually do parallel cuts to it, but do a lot of air cuts on the edges, which is not necessary. Another way to do this was also doing a pocket, creating a pocket over there and working in a pocket area way only. But sometimes you had to create, okay, how much of an offset I want to give at the edges over there. Different ways of doing it. What we've done here is actually created a specific operation for cleaning out corners. If I were to open up the operation itself, the geometry is just the edge over here. If I were to show you this edge itself over here, this is the edge that has to be picked. And I don't have to pick anything else. Over here, by the way, the direction is important. Okay, it'll always work on the left side of that line. And what it'll actually do is it takes this corner over here and this corner over there, and it'll automatically make that finish off this edge over here. If I were to show you what's actually going on further on, we have our tool, of course, and in my technology, we have, of course, our step down and step over. How big of a step over do we want to have on the part itself? Whether we want to do zigzag or one way, those are the options we have here. And if we want to have a wall offset. When I run my simulation, you'll note, let me do it without the solid verify, so you can see the toolpath a lot better. What you see actually happening is that in the clear offset on a profile, what would happen is if you pick this line, it'll go all the way out over here. This line over here will be actually having a geometry up until this area. The toolpath will be up until this area over here. This automatically cuts down the excess area, and it only works in that corner. It'll automatically create a corner going horizontally this way and vertically this way until they meet, and that will be your corner to be cut. This is specifically made for straight corners as shown over here. Now, let me just go a little further ahead and jump to this area over here. This is called a ruled surface. If I were to open up the operation, what you can see actually from here, what we'd like to do is create a tool path that goes from the wide area to the narrow area. So for that, I've chosen what we call rule from my list of different cycles. The geometry, as shown over here, are these two lines over here. If I were to show you the geometry, you can see we pick those two lines over here. We have our tool levels. In our technology, we can do a ref cut, and we also have a step over. How much will the step over be at the wider side, as shown over here? We can also work along or across. We can have our tool path going one way or zigzag. And we have a wall and floor offset as well, where you can finish on the wall if necessary. Let's just do a quick simulation. You'll see what will happen. If the tool will go down, and it goes back and forth on the part itself, clearing off that area. This is called, excuse me, the ruled surface. Now, the next one is actually something very interesting. It's actually something that's used pretty often. Take a case, what we call an O-ring, where we have to put an O-ring inside this area over here, and this, of course, has to be machined out. So what people would like to do many times is to go first down the middle and then go off to one side and then towards the other side. So we've actually created a cycle for that as well. And that cycle, believe it or not, is called O-ring from our list. As you see over here, these are the geometries that have to be picked. The direction or the order does not make a difference. And we have our tool. Now, their tool must be smaller than the actual O-ring itself. If I go to my technology area, first my levels going down 5 millimeters in total. And in my technology, we have an approach angle and a retract angle. That approach angle is actually how it's actually going to spiral itself, at what angle it's going to spiral itself in, and that's for the rough. And if I want to do finish, then it'll finish off the sides as well over here. Okay, and my step down will be every 2 millimeters on the finish. Note there's very little I have to put into here. If I run my simulation, note the tool will go around the middle, and then let's just take a look at the very top view. Again, let me get rid of the tool to be easier to see. We have our tool going around, and then entering and exiting the wall over here with a radius, and doing the same thing on the other side, entering and exiting the wall with using a radius. If I do it showing the solid verify, you see that it actually opened up that entire slot exactly the way it should be done. Okay. Moving right along on the part itself. Two more options I'd actually like to show you. One, or maybe three if I have enough time. We have first this circle over here. This is a typical pocket, and all I want to do is do a spiral cut within the pocket itself. So for that, we have, we have what we call spiral pocket from our list over here. Our geometry again is the circle itself. We have our tool levels, and in our technology, all I have to do is use the minimum and maximum cutting angle or minimum and maximum step over. We have our helical ramping as it goes through into the middle itself. Taking a look at the simulation, as I zoom in, you'll see that the tool goes down. You can see the tool path itself. Let me show you the tool as well. Goes down in the middle and then starts spiraling off to the side as shown over there. And here you can see the spiral cut. Again, looking for the top view. You can see that it worked in a spiral fashion until the very end. And again, I did not have to tell the program much. All I did was say that it's a round circular pocket, and it'll automatically do that spiral cut inside the pocket, which is, by the way, more efficient because you're always cutting very close to the same angle at every point. Plus, the tool does not have any retracts. It goes from the beginning until the very end, keeping itself down and cutting at all times. Okay. Now, let me jump into this operation over here. This operation, let me just position it correctly so you can understand exactly what it's doing. This surface is what I want to machine out. If I take a look from the side, you can see over here, it's going to be held this way where it has actually a point up on top. This is sometimes you have parts that are held like this and you just want to machine out that face over there while it's being held up in this particular way. Well, for that, obviously the home position is facing up because that's the way you're holding the part itself. If I were to open up the operation, what I'm expecting, first of all, as you can see, I have to pick my geometry over here, the line itself. And, by the way, you can see that over here, that I picked that one line over there. We have our tool, and we have our levels. Our upper level in this particular case is that point up on top over there. That's my upper level. And my lower level is this floor over here. In my technology, we have our step down, how much I want to step down every single time, and our clear offset. The clear offset is actually what controls the width of this area over here. So if I want to click on clear offset, I'll click on this line over here, which is away from that line. I'll get the value that I need over here, and then of course we have our step over. Now let's take a look at the simulation. Now the beauty of this is that when I'm cutting this way, let me just get rid of this for a moment. Let me turn the part to the side. When I cut this way, note that the top is relatively narrower, but as it goes further down, it widens its cut. So it's basically cutting only where it needs to. Again, looking at the top of this part, it went back and forth on top over here, as shown over here. Now, if I want, by the way, I can also go in here and change the direction to across. If I do that, what will happen this time, it'll go across instead of back and forth on the side. Basically getting the exact same effect we had before, but this time working across instead of along that way. Okay, I'm going to stop over here. What I basically wanted to show, first of all, we have these canned operations. We have also recordings on them as well on our site. It's definitely something that can be used by almost anyone for any situation. Now again, for example, on a part like this, even though of course if I want, I can start fooling around with exactly how much I want to go down each time, have a different type of geometry, and so on and so forth. But the idea is that it automatically figures out how much it has to go in, saving time as far as going across, what's the distance, and as it goes further down, it gets wider and wider on the part itself. Okay, and as I said, I'm going to stop now, and if there are any questions, now's the time to ask. Okay, as I said, by the way, it's not created yet, but it will be very shortly. We will be having, we're working on it now. I believe hopefully by next week they'll have it on our site. We'll have a tab called SolidCAM University where the recordings of these webinars will be available for everyone to view. Okay, I give one more moment for anyone who has a question. Okay, first of all, thank you everyone for joining. Our next webinar will be next week, next Wednesday, at the same time, and the We will be discussing creating and working with open packets, as we'll also be discussing creating and placing fixtures in the parts itself. Again, thank you very, very much for joining our webinars, and see you again next week.